One, two, three. Good evening, slewers, and welcome to another episode of Practical Astronomy with me, Paul Cox, and we are talking about the primordial debris, the kind of builder's rubble left over from the formation of our solar system 4.5 billion years ago. Yes, those lovely dirty snowballs, as we like to call them, comets. Apologies for the grandfather clock chiming 11 here in the UK. I hope you've had a good day wherever you are, or a good morning, or a good night, one of the two. I know it's a Labor Day weekend, isn't it, in the USA? Labor Day tomorrow, but in the UK we had our bank holiday last week. But hopefully there's loads of you out there who are able to maybe tune in and watch the live Slooh telescopes tonight. And don't forget, this is a regular show on a Sunday evening. And today really is a prelude for a show tomorrow night, Monday. When I say night, I can't say night, can I? It's wherever you are. It's actually going to be 3 a.m. here in the UK. That's 0200 UTC, which is 10 p.m. Eastern in the United States. That's tomorrow night, Monday night. And we have got a very special show planned with Slooh storyteller Helen Avery. She's going to be joining us. And we've got Slooh astronomer Dr. Paige Godfrey. She's going to be joining us while we watch live missions of that absolutely fabulous comet that's around at the moment, 21P Giacobini-Zinner. My goodness, that's going to be... we've been enjoying some great sights, haven't we? Anyway, listen, we're going to be focusing kind of around comets tonight. So if you've got any questions, really associated more with the kind of practical astronomy side of things, how to look at comets, how to choose comets to view in the Slooh telescopes, which processing recipes, stuff like that, something comet related, then all you got to do is post those over in the discussion boards. And let's hop over there now while we enjoy actually on the homepage there. That is from Michelle P. Michelle's been sharing some great images in the observation log on the homepage recently. And this one, she says it all. Wow. Lagoon Nebula. That's from earlier on this evening. So let's have a quick look, see what else is there. Oh, there's a Saturn from earlier as well, from Canary 4. Gosh, that's a really cool image. Not in color, but wow, that's looking pretty nice. And Alberio. That is, hey, listen, we're going to be talking about viewing this comet through a pair of binoculars tomorrow night. And if you have got a pair of binoculars, we're going to tell you exactly how to find Comet 21P. But while you have your binoculars out tomorrow night for a bit of comet watching, you have to look at what I think is actually the most beautiful pair of stars. It's a binary star pair, Alberio, and the color in this image that we're looking at now just does not do it justice. When you see them through a pair of binoculars or even a small telescope, the color difference between the orange and the blue is so beautiful. It will take your breath away. I think the most beautiful stellar sight in the night sky. That one maybe not so pretty. That's Betelgeuse. Shall we say his name 3 times? No, don't. Anyway, let's hop over to the discussion board. So we're going to hop over here to community, up here to most recent. Let's see what everybody's talking about. Good one there. Unknown object. Hey, listen, if you haven't read that one yet, that's pretty cool. That's from Tony E., one of our near-Earth asteroid hunters. Now, Tony actually heads up the A-Team, which is a group of Slooh members who track near-Earth asteroids. And in a mission that he scheduled the other night, he spotted this strange, unidentified object. And who knows, that could be a discovery. But we're going to hop over here and we are just going to take a quick look to see what questions we've got in here already. So, David H. Hey, David, how are you? David would be interested to know if this one, Comet 21P, will be naked eye visible, because that appears to be the way it's acting, and that would be cool. I remember Hale Bopp in 1997. Boy, Hale Bopp was one heck of a comet that reached across the sky. I think it was a dawn comet, wasn't it, when it had that huge fanning tail on it. David, very unlikely that Comet 21P is going to get to that level, to Hale Bopp level, but we are still hopeful that it may reach naked eye visibility. Naked eye visibility basically means with the unaided eye, so not looking through binoculars, not looking through a small telescope. And to do that with a comet, it's got to be probably at least magnitude 4, 5, maybe, certainly 5. And you'd have to have pretty good dark skies to be able to see that as well. But it is already a binocular object, and you don't need a great pair of binoculars, just a good average pair of binoculars. So anything that you'd really use for bird spotting, you should be able to make out Comet 21P in them. And we're going to share with you exactly where to look and how to look, and set yourselves up to be able to see Comet 21P from your own backyard with a pair of binoculars. I warn you now, it is best to get up early. So this is not going to be a late night to see Comet 21P. It's going to be getting up a couple of hours before dawn, and that's going to give you the best chance of seeing this little comet. And I have already seen it through binoculars, and you can already see its kind of dense coma, which is its head, the brightest part of it. And I just made out the other night, the conditions were not great, but I just made out, I wouldn't say so much of a tail, but I certainly saw that the object I was looking at was tear-shaped, and we'll see it in some of the images later. But anyway, David H., you're also asking, I was curious if the SOHO satellite has picked up anything of the remaining pieces of Comet 2017 S3 Pan stars yet. that one or one of the others. It was that one. And Slooh members, I agree with you here, David. It was great, wasn't it? Just watching this over the course of a week or two. And Bernd Lutkenhoner, he alerted us. He's one of our best Comet Hunter members and tracking comets. And he alerted us to a couple of outbursts that Comet C2017 S3 Pan-STARRS went through. And a comet outburst is normally when the gravity of the sun or maybe a planet as it's passing that, kind of disturbs its structure and it exposes some of its volatile ices. We'll be talking about this in even greater detail on 21p tomorrow night. But they're made up of ices and dust, basically. And these ices are really volatile because it's not just water ice. There's a lot of other kind of ices there as well. And what happens is when these get exposed to the solar wind and the solar radiation, they do what's called sublime. And this is when ice turns directly into a gas. It doesn't go through a liquid form in between. It goes straight from ice straight to gas. So if you see some, oh, what do they call it? Dry ice, when you see that, creating a fog in a TV studio on a movie or something like that, that is ice sublimating. It's not going into a pool of liquid, it's going straight into gas. And that's exactly what these comets do. And anyway, so it's a precursor. Seeing an outburst like that when new material maybe gets exposed can be a precursor to the comet breaking apart. And that is what we witnessed with Comet 2017 S3 Pan-STARRS. What was it? Probably 3 weeks ago now. And I know that Tony Evans, he said that he had been checking the SOHO satellite. So the SOHO is a space telescope that's continuously trained on the sun. And it actually has one view which looks at the solar corona, which is the enormous outer atmosphere, the crown, which we normally only see during total solar eclipses. But the SOHO telescope sees it all the time because it blocks out the sun right in the center of its imaging device, its little telescope. And what we see in the background is stars, but it does mean that we can see comets as well as they orbit the sun, as they go around the back of the sun from where we are. Now, what we were expecting to see, and David mentions here that he remembers Comet Ison. When Comet Ison did the same thing a few years ago, we saw the debris come out from the other side of the sun. So when a comet gets closest to the sun, that's what's called perihelion. And obviously, when they get close to the sun's gravity is acting really strongly on that object. And these things are just loose conglomerations of material. It doesn't really take very much to disturb them and break them apart. But at least we saw the debris after Comet Ison re-emerged from behind the sun. But with Comet S3 Pan-STARRS, we have yet to see, I believe, David, I haven't seen any reports that anything was spotted in the SOHO on the kind of trajectory that we would have expected to see any debris. So chances are it was a very loose conglomeration and it basically broke apart in such small pieces that it was probably blasted by solar radiation, and most of that material didn't actually make it out. Certainly not to be visible in telescopes afterwards. But anyway, let's hopefully somebody might be able to confirm that. Anyway, Cameron M. Hi, Paul. Is there an astronomical term for when a comet is visually close to another object? Well, this is called an appulse, I believe, because there are two words in astronomy that do get a little bit mixed up, and a lot of people say that it's a conjunction, but I believe actually it's an appulse when two objects visually look the same or close in the same position. Because Stephen A, you've seen Stephen A's, we'll look at the post later on in the live cast because it's brilliant. I spotted that Comet 21p has got a couple of really, really photogenic opportunities coming up on and around the 10th, actually, when it's at perihelion, when it's closest to the sun, when it's going to pass directly in front of the open cluster M35, I think is the one that it's passing. I know it's passing M36, M35, and M37. So I think it was M35 or M37, but we'll check this later because we're going to take a look on the star charts later to have a look exactly where Comet is. But anyway, Stephen A. Always posts these brilliant um, alerts really in the Slooh discussion board to alert other members to stuff that's happening. And Stephen has produced this great list. It's kind of the almost the playbook of Comet 21P and all of the objects, all of the deep sky objects, which might be, I think there's some galaxies in there, nebulae in there, there's certainly some open clusters in there, and some other objects that Comet 21P is going to pass very close to. So we'll actually be able to capture images of 21P as it moves in front of these background deep sky objects. So we'll take a look at that a little bit later because that is really, really good. And I think it's a pulse anyway, Cameron. But I'll check on that and we'll get the definitions out. So Daryl S., what are you saying here? I know this question is off topic. Oh, sorry then, we won't deal with it. Only joking. It's off topic for tonight, but maybe at some time you could answer it in the future. Earlier, I posted a question for other members. See if anyone could identify two objects close to NGC 1854 from an image posted earlier on the notice board. Is there an easy way to do this? I'll tell you what, that is a huge potential subject, Darryl. So to do it justice, we'll, because I see a couple of members have kind of answered you, but I'll show you some smart ways next week on the show next week of how to perform some automated astrometry. Now, astrometry is the measurement of astronomical objects. And there's some great ways, and Carol there has suggested looking at sky chart, which is a really, really good way of doing it to identify. So if we just take a quick look at this. So there's a bit of the star chart that Carol shared here. So here you can see that, you've got the Large Magellanic Cloud, which is probably the line denoted around there. So Large Magellanic Cloud is one of the satellites, two small satellite galaxies of our own Milky Way galaxy. So you've got the Large Magellanic Cloud, you've got the Small Magellanic Cloud, only visible from the southern hemisphere. So the Chile Observatory is coming online later. The conditions there look terrific tonight. So if you haven't yet set up any missions for tonight, why not set up a couple of missions to the Large and Small Magellanic Clouds? But so there you can see over the top of it, you've got a lot of other objects marked. But, Stellarium, our planetarium software of choice, the Sky, other planetarium software, they'll do it. But there are some other smart ways of doing it as well. And we'll go through those next week, Darryl, because that would be a really good thing actually to go through. So we'll do a bit of that. Simon B, is there a key legend available for the chart, please? That's talking about that. Carol is replying there. Okay, so you lot are under control for that. So let's have a quick look to see what we're going to have a quick look at related to comets over the next half an hour. So we're going to take a close look at the different mission processing options. Now, these are called, we have talked about them before, but we're going to talk about them specifically in relation to comets tonight. And these are really what's called, they're not really called processing options. They are in the scheduling system, but we actually refer to them as processing presets. And you'll see where astronomer members can select that. And it changes not only the data that's acquired for your mission, but it also changes the real-time processing. And it's the real-time processing that we can watch live on the telescope pages. And it's also the thing that generates the snapped images, the PNGs that we snap and land up in our My Pictures area. So we'll take a quick look at that because I've done a couple of cool examples there to show you on 21p. And actually with 21p at the moment, there are two processing options that I'm using every night because they show very different things. So, that's always an option as well, that you can set up a series of missions for a comet and you can get the best of all worlds by setting up the different processing options. So we're going to take a look at that in relation to setting up some missions, how to identify comets that are currently visible. Now, we might leave that till the end because, frankly, that might fit quite well into next week. If we really do a kind of how do you find out about stuff, you know, where to find it, where in the sky it is, how you find it, how do you find a comet, how do you identify other objects that might be in your images? So we might roll that one out till next week. We are going to do a quick recap on setting up a coordinate mission. And this week, for that, we're not going to use Stellarium, the planetarium software. We're actually going to use something that anybody can use. So you don't even have to download any software to do this. We're going to use what's called the JPL Horizons system. And this is, you can see it here, Horizons web interface. This is a page. We'll share the URL in the discussion boards later. But I'm going to show you how to use this to generate the coordinates that you're going to need to put into your mission when you schedule a coordinate mission. So we'll take a look at that as well. And we might not take a look at how to create a Comet time lapse. We might if we have time. So let's get on. Let's hop over now and see what conditions are like over on the telescope pages. So as you all know by now, up into telescopes on the left-hand side, don't forget you can go to, so you can see here immediately actually. So you've got Slooh Chile Observatory. Chile 1 has got a little red dot next to it, which means it's not open yet. But we'll take a look in a sec. In fact, let's take a look now. Let's see what conditions are like. So I'm going to click on the telescope link page. I'm going to go to there. So we can see that the telescope is offline, but down here, we can take a sneaky look at the all-sky camera, and there we can see the all-sky camera. We've got a clear sky there. Sun is just setting, so the domes will open up as soon as the sun's gone down, so that'll be cool. So it's looking like quite a nice night. It looks like it might be a little bit of haze there. Difficult to tell, though, at this time of night. So you can always use the time-lapse because it's often a lot easier to see any haze. So that's last night. If we skip forward to today, and there's today, you can often see any cloud and stuff like that a bit easier. So, yeah, bit of cloud there. Yeah, you can see there's a little bit of haze there. So, we'll keep an eye on that. But, we've got light clouds to partly cloudy skies forecast. But hey, look at the forecast from Chile this week. Wow. Talk about it turning to spring later on this month down in Chile. We've had a really good clear winter, actually, haven't we, down in Chile? We've been fortunate. Anyway, let's hop back to the telescopes and let's hop down to Slooh Canary Islands because there we can see all of the live missions that are running at the moment. Oh, look at that. Look at the Trifid Nebula in Canary 3. Oh, let's take a quick look at that. Sorry, folks, you know me. I'm like a dog seeing a squirrel. I've got to take a snap of that. Whoa, that's lovely, isn't it? Now then, I bet you there's no moonlight around tonight. Or not at the moment, because we've said it before. Canary 3 is often badly affected by moonlight, turning the images kind of bluey green color. But that's looking pretty good. So how do we tell if the moon is up? Well, first of all, we've got our sky chart over here. It's showing us the location of this. Gosh, look how close Saturn is actually to this very scene. I might take a look at the old star chart later. Now, you've got to make the most of these objects because these are summer objects and they are disappearing rapidly into the southwestern sky. So make sure you catch those. But let's take a look at the all sky in the Canary Islands. And ooh, look at that. Definitely no moon, but look at that. What a fabulous night. You can see we've got some haze. So the dark line there that we're seeing around this edge down by the domes, you've got an island over here, and the rest of it is actually the horizon of the ocean, right? Curved around in this kind of fisheye angle lens. But one of the things that I would point out to you in this is look above that, and you can see there's another layer of white, especially over here. We can see it up in the top left, and that is haze, right? So it's an absolute it's something to look out for when you see white like that above the darkness of the horizon, because basically what we're doing here, we're seeing the top of the clouds and haze here. In fact, we can even see down to the coastline there with some of the lights. Then we see the horizon, but we can see that this is high level haze. In other words, we're peering through it for our images tonight. But look at the Milky Way. Look at that arching up through there. That really is absolutely stunning, isn't it? So I think we got Jupiter over there. We've got Saturn there, and then Mars, nice and bright there, I think. I haven't checked the sky charts, but I'll have a look at that. So anyway, conditions looking pretty good. So let's take a quick peek at what we've got in the other telescopes. Let's check the wind, actually. So we go down here again. This is on all of the telescope pages. Let's check the weather, and we can go to current conditions. We've got light clouds forecast for tonight, but let's go to current conditions. See what wind's like. Oh, wind gusts are up again, 8 miles per hour. So let's check out Canary 1, the half-meter telescope. That can be badly affected by the wind, but that's not looking so bad at the moment. So this is going to be the pink and blue nebula coming out. You can just see the nebulous regions here, and that'll hopefully go to color. We have, by the way, we think we've identified a small problem. Now we've finally managed to diagnose it, what's going on with Canary 1. Some of the missions are not going to color, but we think we've tidied that one up. So keep an eye open for that during the week. And as soon as we've done that, we're making some other changes. We will be republishing. It's been long promised, but we will be republishing the processing options, the processing presets. So you'll have that by hopefully this week as soon as we finish those. But anyway, hey, look, talking of comets, somewhere in this field of stars is Comet 129P Shoemaker-Levy 3. Wow. So we know with a comet's name, because I'm finding this up here, and it's also over the image as well in the HUD head-up display. But this is Bernd, our Comet Hunter member. So he's trying to track Comet 129P. The 129 means it was the 129th periodic comet to be discovered. We know it's a periodic comet because it's got a P after it. So the one that we were talking about earlier, which started C/2017, S3 Pan-STARRS, that was not a periodic comet because it didn't have that kind of naming for it. So what we know with that one is that it's a non-periodic comet. So it was its first journey into the inner solar system, and it was on a kind of orbit that meant it was going to stray well outside or zoom back out into the outer solar system, possibly not even coming back again. But basically a short period of comet, a periodic comet, is one that orbits the sun in less than 200 years. They are thinking, or they may have already actually tweaked some of this, because as observations get better, it might be extended, I believe, out to 400 years. So a comet that returns every 400 years or within 400 years would be considered a periodic comet. So keep your eyes open on that. Now, you'll notice that we've gone to a new mission. So you might be asking yourselves, okay, Bernd, well, if you set up one mission for this comet, then surely you've got your images, so you don't need to set up a second mission. Well, this is at the root of comet discovery and just about every kind of astronomical discovery you can think of. And Tony Evans did it on his unknown object that we were looking at the top of the Livecast. And you have to have more than one image. If you just take an image of an object, so let's say we look at this, we identify which are stars, but one of the small dots is not a star. We know it's not a star because it's not in any of the surveys, it's not on the sky chart, so we know it's not a star. But what is it? Well, one image won't tell us anything about it whatsoever. It will tell us where it was on an instant of time. But what we need to do is we need to gather up at least 3 observations, 2 to identify a moving object, because sometimes, frankly, it's difficult to even identify a moving object against a mass of stars like this. This is quite a crowded star field, isn't it? So spotting, let's say, an asteroid or a small comet amongst that little lot is going to be difficult. So if you take two lots of images spread apart by any period of time, usually at least 5 minutes, but sometimes it's an hour or something like that. Depends how fast the object's moving. So if you then do that thing that we did when we were creating time lapses and doing a blink compare, so aligning both of the images and blinking between each one, all of the fixed stars in the image, you don't notice any difference on them at all. But what you will notice is any moving object very, very easily in that time-lapse animation. So that goes for not only asteroids, but it also goes for comets, and also for one of my favorite planet discoveries. Well, it's not a planet discovery, of course, now, but of course it's that tiny dwarf planet, Pluto. Hello, daughter. Daughter's just come in. And that was Clyde Tombaugh. Now, imagine this poor guy, all right? He wasn't taking images through scientific grade CCD cameras. He was using one of the telescopes at the Lowell Observatory. And he was using, I think it was 20-inch square glass slides. They're not really called that, but it's called a photographic plate. Sorry, I had a bit of a blip there. It's called a photographic plate. He had to sit at that telescope and make sure it didn't drift and the stars didn't move, because he had to take exposures which were hours long to be able to identify that tiny moving dot of Pluto's. But not only did he have to do that once for several hours just to get one image, but he then had to do it again several hours later. He compared it to also photographic plates that he took at previous nights as well, and he put it into that great big, beautiful piece of equipment. It's called the Blink Comparator, and if you ever get the chance of visiting the Lowell Observatory, make sure that you go into their kind of little exhibition space and you can look through the very eyepieces that Clyde Tombaugh looked through, and they've loaded up the 2 discovery plates or copies of those plates where he discovered Pluto, which at that time was Planet X. So he went into Dr. Slifer and said, Dr. Slifer, I've found your Planet X. And so it's always the same, and that's what Byrne's doing here. So he's trying to identify here. We'll take a look a little bit later to see how bright Comet 129P Shoemaker-Levy 3 is at the moment, because then we can see exactly what a hard task Byrne is normally doing something pretty challenging when it comes to comets. So I suspect that comet's going to be fairly faint now, but if we grabbed images of both of the missions and blinked, compared them, we would probably find that there's a very small dot in there, which is moving from one mission to another. So really apt, isn't it, that we popped in to see that particular one. Let's just take a look, see what it looks like in the Canary ultra-wide field. Oh no, we've hopped on to the next mission now. This is NR Lyra. So, okay, that looks a bit like a nice gap there. Maybe a dark nebula or something like that. One of Michel P. What are you up to here, Michel? Let's take a look. Anyway, let's take a look at the other ones. So let's hop back. We'll take a look at, okay, pink and blue. Oh, pink and blue nebula did just come in. Oh, and I'll tell you what, while we're looking at this, I've forgotten who posted it. May have been David, but take a look in the discussion boards, because he's done quite a lot of work on a whole bunch of images that he took of this very nebula, the pink and blue, and you get lost in it. I know Carol mentioned as well. She was the same as me, got totally lost in that. Now, by the way, if you are new to Slooh, what we're looking at here is we're looking at live images coming in from the telescopes in the Canary Islands, the flagship observatory at the Institute of Astrophysics of the Canary Islands. It's nice and dark there tonight. We were seeing the Milky Way. Let's take another quick peek at the Milky Way, because it was looking pretty cool, wasn't it? Look at that. The Milky Way stretching across the sky there. You can see the domes over there on the left. Some of their LCD lights. A bit of tape's come off there. So I'll need to get that fixed. But anyway, let's take a look, see what else. So we've done Canary 2. Let's take a quick look at Canary 3. What's going on here? Globular cluster. Not the best telescope for globular clusters, but is that quite low down? Is this looking fairly? Yeah, it's fairly low down there in the south So we're probably in that haze, which is why we're getting it a bit noisy. We do still have the problem actually with the Canary 3 system, that the CCD camera is not reaching its cooling temperature at the moment. So that's what's counting for making some of the missions a little bit noisy there. Let's take a look. Oh, there's Vega. Oh, the star of my favorite film, Contact. Um, Gosh, it's when they hail to Vega, isn't it? Have you seen that movie? Um, so anyway, let's take a look then at comets. So let's take a little look first of all at some of the images, some of my missions. So we go up to my pictures, and a lot of you will know that I've been setting up special missions recently of Comet 21P, Giacobini, Zinner. You know, I want to pronounce Giacobini as Giacobini, but of course the guy was French, not Italian. Why has he got such an Italian name? Surely Giacobini is an Italian name. Surely. Anyway, let's hop forward a bit. Let's see if we can pick out some of our missions. Here we go. Right. So I've got exactly what I wanted here. So we've got a couple of missions from the other night. Let's just see. I'm not sure if we can do this. Yes, we can. That's good. So that's from one mission there. And I'm going to select this mission for another. I just want to check something here. So these are all of the missions. These are all the images from one particular mission. All right. So here we can see, in fact, this was quite an interesting one. This is last night because it was getting very close to the bright star Capella. And you can see in this bottom left image, if we just click download it, zooms it up. Can you see this? You might not be able to see it on the screen share very well, but you can see there's this kind of arc going all the way through the image. And you can also see it kind of comes over here as well. Well, that's actually the bright reflection managing to hit the telescope obliquely. Capella is such a bright star that it's actually affecting this image as we see Comet 21P, Giacobini Zinner. There it is, that first time we've seen it this evening. Now, this is not live, this one. This is from last night, one of my missions last night, because it's not viewable until well after midnight. So really, I think I've set up special missions tonight, which we'll go into later, of 0100 UTC. So that's in an hour and a half's time will be the first mission, but it's incredibly low at that point. But what we've done is we've set up these missions all night long. So anybody who does want to do a time-lapse animation, make sure you grab images, piggyback on all of my missions. If you don't know what that is, I'll show you later. But anyway, look, there's let's just take a look at this one here. And what do we got here? I'm just trying to check something here. We're going to hop over to the other mission here, and it's not going to give me what I want to show you. What I was hoping to show you was the difference. Let's go back to missions actually, and we'll see if we can filter down. We'll filter down maybe into some of our Canary 2 telescope comet missions from last night. Let's just take a look here, trying to find the difference. Do excuse me on this because I want to show you the difference between one processing option and another. And I'll tell you what I'm going to do. I'm just going to hop over to another window so you won't be able to see something for the moment, but I can actually find out the answer to a question that you don't even know I'm posing myself. Easier if I look somewhere else. Let's take a look. So I'm just checking last night the missions that I set up. So what have we got? Where have we got them? There they are. So we've got, no, foiled again. All of the missions that I set up for it last night were using the same processing option. So I'm just going to try and show you something in a slightly different way because I know the previous night. So do excuse me, folks, because we want to get on to, in fact, while I load that up, So that's loading something up in the background that we're going to use later. Let's hop on to how we set up a mission for um, Comet 21P. And as you know, in fact, if we hop over to the discussion boards, we can take a look at time-lapse animation that, here we go, Daryl, no, was it Daryl? No, it's Stephen, wasn't Daryl? Oh, here it is, it's from John F. And this is great, John. So John piggybacked on some of the missions from Canary 3 the other night, and he's turned this into an animation. So this is what we're talking about. Any 2 frames, if you had 2 missions, I mean, this is an easy Comet to see, isn't it? But if it's like 129p, which is probably very faint at the moment, the one that burned is chasing. You know, it's you're not going to be able to see it like this, but as soon as you animate it, it's really easy to see something moving against all of those fixed background stars, right? So that's the reason why you might want to book up some telescopes, book up some missions for this. So let's hop up to schedule the telescopes. And don't forget, it's only Slooh Astronomer members who can set up a coordinate mission. So Slooh Apprentice members, you can choose from, you know, all of the Slooh 500, which is turning into the Slooh 1000 by the end of the year. But we want to go over to set up a mission up by telescope. And in fact, I'll just show you here while we're here. Let's hop over to Canary 2 and I'll show you these special missions we've set up. So keep an eye open for my ugly mug as it crops up. Loads of ugly mugs there, of course. Let's wait for my, there it is. Right, so here you can see the first Comet 21P Giacobini Zinner mission that I've set up tonight is at 01:15 UTC, so that's 9:15 Eastern Time. And what you can do is if you're looking at the schedule, you'll have one of these buttons on my missions, an auto save to my pictures. If you press that, then you'll automatically have those images from my missions saved into your own My Pictures. But what you can see here is we've set these up every 15 minutes on Canary 2 tonight, and on Canary 3, it's even more because we didn't want to take up too much of the schedule on Canary 2. So here you can see the earliest one here. We were able to go a bit earlier because Canary 3 has a lower horizon limit, so we can capture objects when they're lower on the horizon. But bear in mind, the images from this mission are not going to be that great because it's incredibly low in the sky. I think it was only 7 degrees or something above the horizon at that point. But anyway, make sure you piggyback all of those because they run all the way through to dawn. All right, so you can set up your own missions. And what I've done with all of these missions is I have, and I'm going to show you this actually in a second. I've done it on a fixed background of stars. So the comet isn't moving so far that over the course of 5 hours, it would move out of a single field of view of either of those 2 telescopes. So what I've done is I've set up a kind of average. In fact, I'm going to show you this now because this is a real classic piece of how to set up for time-lapse animation. So I'm just going to get rid of that, bring something else up. I've got to change a couple of little buttons like this, and hopefully you can see that. So I'm on a different machine tonight, so I'm not using Stellarium, so I'm using the Sky Planetarium software here, but the principles are exactly the same, right? So we know that if we're using Planetarium software, the first thing we need to do is we need to check the location, because an object will be in have slightly different coordinates depending on where you are in the world. So yeah, we're on Teide, that's the Canary Islands Observatory, so we've got that. Then we need to set up the date, so just click that and it's on the computer clock. I'm going to stop that and actually look at that. You can see here, let's just frame that and go slightly further out. You can see just how close 21p Giacobini Zinner is to that bright star, Capella. So in the Canary 3, in fact, is it going to still be there? I'm just going to move the time forward. So I'm going to change the time. So, because we know it's not high enough there, we can see over here on the left, it's actually at -8 altitude. Now, let's hop forward in time. That's 1 hour, 2 hours, 3 hours. So it's just far enough up now. Now then, what I was going to show you here is how I deliberately offset my missions. Because if you recall, let's just call this back up. If you recall, look at my image here. The comet's coma isn't centered in the image. And I've done that deliberately because I know that the comet's tail is heading off right. That's west in this particular image. In all Slooh images, west is right, east is left. So we know actually that the sun is to the left, to the east of this comet, because it's that solar radiation which is forcing that tail in that particular direction. So if we just look up the coordinates of this comet, it's always going to be centered if those are the coordinates that we use. But I deliberately offset those coordinates, and I'll show you how I do that. And let's set up this mission together right now. So let's say 0200 tonight. Yep, that is going to be correct because it's on the 3rd, because it's after midnight UTC. Let us zoom in on this because I've got the fields of view of the different Slooh telescopes. So if we just centered on the comet, you can see there that Capella is out of the wide field of view of the Canary 3 Deep Sky Telescope, but we want it in the view. Okay, so this is all we do. We drag it across and we're framing up how we want our image to appear. So let's offset it like this, I reckon. Actually, let's just go up a little bit further. So we'll have the bright star Capella up in the left-hand side, and we'll have Giacobini Zinner down here, plenty of room to see its tail going off on the right-hand side. So the actual coordinates that we want to use for our mission are in the center of this particular view. So all I do is click. And it doesn't have to be that accurate because we know, look, we've got plenty of leeway for how both of those objects are. So now we're over here on the left-hand side. It's showing us the coordinates for that particular point that I've centered there. I'm just going to change the coordinate format to decimal because that makes setting up the mission a lot easier. Let's hop over to here. And so we're going to set up telescopes. So if you haven't done this before, I'm just going to close down a couple of windows here. You go to telescopes, you go up to schedule telescopes, we go to telescopes. We're setting this up for Canary 3 because that's got the largest field of view. So we'll do one actually for Canary 2 as well. Let's just switch on the Canary 2 ultra wide field of view as well. So there it is. So we'll have another field of view there. I just need to get on another screen so we can close that. And then you can see that second box. So those coordinates will also be okay for the Canary 2 ultra wide field. So let's hop over to the schedule. Let's hop over to Canary 2 to start off with and see if there's a mission slot around that time. No luck there. No, there's nothing available there. So we've got to use Canary 3. So let's hop down and see what's available at that time. 0200 we said. I bet there's this bloke called Paul Cox who's got 0200. Yeah, there he is. He's already got it. But listen, if we look at our sky chart, right? If we change the time on this, we can see that even an hour later or an hour earlier, that both of the objects are in the field of view. So we can still use those coordinates, even if it's on the next mission. So let's go 1, 2, 3, 4, 5 minutes. So this is the next mission. We can still see that Capella's going to be there in the upper left. We're going to catch Comet 21P, Giacobini Zinner down in the bottom. So we're going to select that time slot. So we're going to enter coordinates, please. Come down here. I'm going to, thankfully you can see the entire screen. I'm going to right click, say copy, right ascension, and that's why I love doing it in the decimal, because it means that you don't have to worry about all of the boxes. Let's copy over the declination coordinates. So that's just the equivalent of latitude and longitude on the celestial sphere. Now, stars, don't forget, they always stay at Capella, right? If we were to click on Capella now, we can see its coordinates. Its coordinates don't change. They kind of do marginally, but over thousands of years. But its coordinates don't change. You know, we could go to tomorrow night now. Let's click to tomorrow night. Those coordinates don't change at all for Capella. But for planets, for asteroids, and for comets, they do change, even over 5 minutes. So look at the coordinates here, and we'll change it minute by minute. And you can see those coordinates changing, and you can even see the movement of the comet across the sky as each minute progresses. But anyway, look, we need to do this before we run out. So the other nice little thing I always like to do here is I copy the name over because I'm lazy, and I say Comet in front of it and just do a, unfortunately, it's going to strip that out. Check visibility, it's going to tell us it is low, so image quality may be affected, but that's okay. Now on this one, I'm definitely going to go for bright galaxy or comet, mainly because we've got that bright star in there as well. So we'll talk about that in a sec. Schedule mission, thank you very much. I'm going to add my tags to this, comet, and then I do my little thing in there as well. And I add that. Absolutely. Got it. Yes, please. So make sure you piggyback that mission from 0205 tonight, and you will capture. So you can see here the coordinates are different to the ones I've set up already because that's got the comet offset to one side. But piggyback this mission and you'll get that cracking little composition of Comet 21P, Giacobini Zinner, and the bright star Capella in the same image. So that would be quite cool. Now, what I was really going to do was show you this on a normal night. So if we, let's hop over to tomorrow night. Let's hop over to a better time when we know the comet's going to be higher. Let's go to 0430 maybe. And the comet, you can see, has disappeared from our field. And that's because it's moved on and we haven't. So I'm going to center it. And on this one, I want to set this up for, let's say, the Canary 1.5 meter telescope. So there we can see its field of view. So we could just set up a mission at this particular time using these coordinates. But if we do that, we might lose some of the comet out of the field of view over to the right. And we know at the moment, you have to have knowledge of which way a comet's tail is pointing at the time, but normally that's just away from the sun, so away from east usually. And in this particular case, it's virtually horizontally over. So all I'm going to do now is I'm going to compose my image. So I want the comet's coma to be over there on the left, which means the comet's tail is going to span out over here. And let's say for this particular one, I'm really interested in catching as much of the comet's tail as possible. So first thing we want to do is click in the middle of the image, because that's roughly where we want the center of the image to be. Let's just click down there. So you can see I'm on mouse click over here. So we need to go to Canary 2. We need to go to tomorrow night schedule, 0430. Oh no, because we've blocked them out for tomorrow because we're doing the show. So the schedule will be released tomorrow. So let's go to Tuesday, which means I've got to hop forward in date there, do the whole same process again, find the comet, center it, offset it to where I want it, then click in the middle, and that star is roughly in the middle. Let's hop down now. So this is the night of the 4th, don't forget. So in my planetarium software, it's the 5th because we're past midnight. So I'm going to go down here, 0430. So there's already a Slooh mission in there, that'll be released, but we also know that let's change it by 5 minutes, and 1, 2, 3, 4, 5, it doesn't move that far. And what I've done this week is I've picked the central time of all of the missions I'm setting up. And positioning it at that point. And then you watch this as I run back an hour at a time. So we've got about 5 hours of missions for Comet 21P. Rock back the time, we know that, look at that, even 3 hours. That's how far it moves. So we know that over how long is it taking to cross the entire frame? So it's just entering the frame there. 1, 2, 3, 4, 5, 6, 7, 8. It would be about 9 hours. Now, it's not visible for 9 hours every night, so that we know we can pick that kind of central spot, and we can be quite happy that the comet is always going to be visible, and it's going to pass through the entire field of view, certainly on the missions tonight. So anyway, let's take this. What should we do? Anyone got any preferences? Should we do 0425 or 0435? I'm going to do 0435 because it's a little bit higher. So enter coordinates once again. Hop over to our planetarium software. Copy the right ascension. That's in there. Control V to paste it in. This is such a foolproof way of setting up your coordinate missions. It really is, because there's no typos involved, because you're cutting and pasting directly from the program. Check visibility. Good news, the object is visible at this date. It's not giving us a low altitude warning, because we can see from our planetarium software over here that it's at 50 degrees altitude above the horizon. If we were to look up altogether, we can see where it is. So, it's good position in the sky. Now, for this one, we said we want to get as much of the comet's tail detail as possible. So to do that, we're going to sacrifice something. We're going to sacrifice color, because we have a special processing option, the image processing option, called multi-luminance. And the one that we want is multi-luminance 50. So as you know by now, the color images from astronomical telescopes are made up of a series of images taken through different color filters. So the CCD chips, the imaging sensors inside astronomical cameras is not like the chip in your phone or your digital camera. They have little color filters over every single photo site. The photo site is kind of the equivalent on the actual chip itself, on the actual sensor itself. But that reduces their sensitivity greatly. So on an astronomical camera, they don't have any filter on the actual chip, on the photo sites of the sensor itself. Instead, we have a filter wheel in front of the camera, which first of all takes images through what's called the luminance filter, which looks clear. It then takes images through the red, green, and blue filters. All of them, when you see them individually, look grayscale. You don't see any color, even in the red image. It's just grayscale. But what we do then is Slooh's patented real-time technology comes into play here, processes those in real time at the observatory, and then shoots them up to the servers and then straight out to the live telescope views that we were looking at earlier. So anyway, the thing to pull out detail is just using the luminance filter. So this particular image processing option is going to take as many images that can fit into a 5-minute mission, but only through the luminance filter. We can then combine those together to pull out more and more detail from the comet's tail. So we've done all of that. We can scroll down a little bit. We can say schedule mission. Let's do our business in here. Actually, I do those separately. So I always add my comet missions a tag of comet, which means I can search for them all. Also, I'll add the comet's name. Absolutely. Got it. Thanks. So there we are. So you can piggyback on that one on Canary 2 tomorrow night as well. And we'll see a great little thing. So hopefully that shows you how I go about framing up these special missions that we take. So it's not just based on the comet's coordinates. The comet is always off center so that we can catch as much of its tail as possible in the images. And who knows what we are hoping for, over the coming week. Excuse me. What we're hoping for over the coming week is that as 21P gets closer and closer towards the sun, it's going to get brighter and brighter and brighter. And who knows, we may even land up with a naked eye comet that we can see with our naked eyes. Now, I'm just going to pull out a little example to show you this. So I'm going to pick out this one. I'm going to pick out this one. And I'm going to show you these. So that is from one of my missions last night, excuse me, that used the bright comet or galaxy processing option. In fact, I'm just going to shift to the previous night as well. And then this one is the outcome of, in fact, let's position these a little bit better so you can see them both on the screen together. And you can see immediately the one on the right was using that luminance only filter. And you can see, we can see far more of the tail. And actually, if you look closely on this, you can actually see even more tail over the last few days. And I think we're seeing a bit of a fan coming up kind of from the comet's coma, the bright head, up to kind of 1 o'clock position from it. And we can see less of that detail in here. But if you really wanted to make out as much of that comet tail detail as possible, then you can combine images and data from loads of missions, and you can then combine it and you pull out more detail. I'm just trying to find another example because I thought I had a faint galaxy. I would like to just show you a faint. Yes, I've got one coming up. So we're talking about these processing presets. So on the left, we've used bright galaxy and comet. On the right, that's the luminance only, multi-luminance. And I'm just about to pull up for you now. Do excuse me, I'm putting this up. Come along. My poor little machine's working hard tonight. Here we go. Right, gotcha. So this is going to be, actually, let's do a like for like comparison. So we're going to close that down. We're going to close that down. We're going to close that down. We're going to pull this one in. So there's one mission, and then the next mission, pull it over. Now, what you can see here is the one on the right used the faint galaxy or comet option. And you can see the coma is slightly smaller. The background is far brighter, so it's actually processed this in quite a different way. It's trying to pull out as much detail as possible. But what that results in as well is the background lightens as well. So you can see here, we've got far more background there than this one on the left, which was the mission before, which used the bright galaxy or comet option. So this is more accentuated on the Canary 1 telescope. So that's something to keep an eye open for. So it's pretty cool. So what we're going to do tomorrow night is we are going to set up loads of missions, certainly for the live show, which is 0200, that's 10 p.m. Eastern time. And we've got, don't forget, Helen Avery coming on. She's going to be telling us about comets through history and in culture and stuff like that. And Dr. Paige Godfrey is going to be joining us as well. It's going to be quite a discussional show tomorrow. So each one of us is going to kind of be on it. We're going to be on in pairs to discuss this and answer all of your questions. So if you have got questions for the show tomorrow night, then please post them there. So let me just hook something over here. Switch that off, switch that on. So that's going to be pretty cool. So what have we done tonight? Well, we've certainly set up a coordinate missions. We've set up a couple there. Don't forget that one on Canary 3 tonight at 02:05, wasn't it? Is that right? Oh, no, that's Oh no, we've now slipped over the night, you see, so I'm going to come back and come back again. Hop down, so make sure you piggyback that 0205 mission, this one here, and you're going to get the Bright Star Capella in there, as well as, in fact, I should probably, if I edit that now, I should be able, if I do a check visibility, we're going to do Bright Galaxy update mission. It will give me the opportunity of also adding in Capella. So that'll be good as well. So there we go. We've got 3 tags, which means it'll be really easy to find in my pictures. So anyway, we've set that up. We've set up another Comet mission to do it kind of offset. Now, if you haven't got Planetarium software, the very last thing we're going to look at, if you've got any questions, we'll take a really quick look at questions after I've just done this bit, because I did promise you to show you an alternative means of getting a comet's coordinates if you haven't got Planetarium software. And you do that by using this website. So it's the JPL Horizons website. I've just kind of zoomed in a bit there to make it a little bit easier for you. You can see the URL up there. No, you can't. I'll post that. Let's post, excuse me, hiccups. Let's post that in the discussion boards straight away. And then you'll all know where it is. So in here, let's just do a new post from here. And we'll put JPL Horizons website. Oops. Fox can't type at midnight. We'll turn that into a link. Unfortunately, it doesn't do it on its own. I'm talking to the development guys to see if we can get that done. Put a couple of those in because the formatting doesn't look very nice. Otherwise, submit that, go back. Right, so you lot can follow along here if you like. So have a look at this post. All you'll do is click that link and it opens up. Let's close down the one I had before. Here we are, JPL, Jet Propulsion Laboratory. It's Horizons Web Interface. So we want to find the coordinates from Slooh's Canary Islands Observatory for Comet 21P. And we want to do it, let's say, tomorrow night. So all we're doing here, ephemeris type, set that to observer, target body in here. We can search for that. Let's see if we can just do 21p. Yes, it will. And top one, you can choose that. Select indicated body. Yes. So we've got Comet 21p, Giacobini Zinner in there. If you won't have this automatic filled out, it actually changes, retains this from one session to another. But observer location. So if you don't know the code for this, you can search. So the code actually that it's looking for is the Minor Planet Center code, which is allocated to an observatory by the Minor Planet Center. And there you can see it's G40 for the Canary Islands. But if you just do a search on Slooh, then it'll find you these. There it is, it's G40. The Chile Observatory is W88. You selected location. Now, when do we want to do it? We want to do it for tomorrow night, say. So let's go 9. And don't forget, so I'm now 3. Let's say it's going to be 04. Sorry, 04. 04. And you can set this to be the couple of days later. Step size. I would do this in minutes at the moment, and actually you could, because it's not moving that fast at the moment, you could pop in 5 minutes, but you can experiment with this kind of thing. Use specified times, so there we go. So there it is. We've done our configuration. We've said ephemeris type observer, target body, that's the one that we're looking for. Where are you observing it from? The Slooh Canary Islands Observatory, G40. The time span, I want you to give me the comet's coordinates between 04 and 06. And that's it. That's all we need. Press generate ephemeris. This will break the internet if we all do it at the same time. 3, 2, 1. Okay, the internet's not broken. That's highly disappointing. You've let me down, viewers. You've let me down. Now, here you can see a whole stack of information here. Got things called orbital elements and all sorts of other properties about this. It's got a key to some of this stuff. But here's the meat. This is what we want. So here on the left, you can see there are dates and times. So at 5-minute intervals, that's why we set 5 minutes. And here from this location, look, can you see this M here? That means that it's above the horizon and it's visible. All right. So whenever you see that, it means it's visible. It's got a couple of other codes in there as well, which are, I don't think on this. There's another. There is a key page that you can go to look these up. But what I do is I always scroll up. So let's say it's to 0200 is the one that we want to set up. That's when we want to do our mission. Now, this is not going to give us the offset that you want. In fact, I need to scroll up because I need to show you what it's saying at the top. What we're interested in is a single line at the time of our mission. So there we go. And actually, the only thing that you really need is this, because we've got the date, we've got the time. Then up here in this column, you can see it's the RA J2000, and that's what you need. You need the J2000 coordinates, and then it's got the declination coordinates there as well. So at 0400, on the 4th of September, 0200 UTC, and this is always in UTC, the comet is going to be located at right ascension, 5 hours, 19 minutes, 20.24 seconds, and declination is 43 degrees plus 43 degrees, 33 minutes and 28.6 seconds. So that's the two coordinates that you would enter into the scheduling system here when you're going to telescopes. When you go to telescopes and you do everything that we did before and try and find a spare slot. Well, I will release all of those slots tomorrow that aren't being used for the show. And so you'd be entering those coordinates in the proper time slot, of course, into those boxes. So that's what we're doing there. So anyway, that is really easy to use, I hope you'll find. It doesn't, though, give you the offset, but what you do know is the comet is going to be in the center of your images if you use these coordinates set up at the correct time. So there's just an alternative means of setting up a coordinate mission for a comet. And of course, you can do the same thing. If we hopped in here, what was the one that Bernd was looking at earlier? It was 129p. Let's take a look at that. And oh, there you go. Top one, the default select indicated body. So there you go. So that would do the same thing. And in fact, that's what we want to take a very quick look at. So let me just switch that off, switch that on. Let's take a look. So Bernd was imaging this a little bit earlier. So we're doing our search on here. Wow, look at that. The comet that Bernd is chasing tonight, Comet 129p Shoemaker Levy 3, is it's at fairly low altitude, but look at the magnitude of it here, 20.51. Now, Bernd could not do that search for a comet so faint if there was any moonlight in the sky during his mission. So he's really pulling out the stops on that one to try and locate that tiny, faint comet that's probably still at quite a distance. Look at this. It's still 4.64 times astronomical units, which is the mean distance between the sun and Earth. Wow. So it's distant at the moment, but it's coming in to see us. There's another cool one as well to look out for at the moment, which is 46p Wirtaten. And let's just take a look at this, because we are going to take a look at this tomorrow night as well. This one is also expected to reach naked eye visibility later on this year. So make sure you check that out as well. Anyway, no, we don't want to see any changes. And let's just hop back, make sure there aren't any questions. And So I think we've got about 3 minutes left. Oh, lovely image. I can't talk about anything. Come on, stay concentrated. Stay concentrated. Can't see when you've got 3 minutes. Done that. We've done that. We've done that. We've done that. Is there a key legend available? Chart? Yep, Carol's done that. No, we're done. Looks like I've been talking to myself tonight. Actually, I know I haven't because I've seen actually that we've had quite a few viewers tonight. So, and the reason why that probably is comets out of just about all objects at Slooh get most members interested in them because they're just fascinating objects, and the more you learn about them, the more fascinating they become. So look at this, look at these images from last night. They really are cracking, aren't they? Let's just open that. It did. Yeah, there you go. So let's just finish off with one of those missions from last night with Bright Star Capello even just putting in a little bit of red down there in there. So anyway, we are going to be tracking this all week long, but make sure you join us tomorrow night. Myself, Slooh storyteller Helen Avery, going to be telling us about comets down the ages, and they are fascinating how they've been perceived down the ages. So that's one thing we've been talking about. Then we got Dr. Paige Godfrey, and we're going to be talking to her about the science behind comets, where they come from, where they're going, what happens to them, why they're green, and any other questions that you would like answered. So that's at 0200 UTC Monday night, which is 10 p.m. Eastern time. We know it's a little bit late, but we're waiting until the comet at least gets a little bit higher in the sky. But don't forget, we will continue with our special Comet 21P missions all week. So you'll be able to piggyback on those by hopping over to the telescope schedules and hopping down, and you just hit the auto save to, oh look, so here's Jeff B. Jeff B set up a mission as well to it. So actually I'm going to piggyback on your mission. There you go. Thank you very much, Jeff. I got your missions and you got mine. Anyway, that probably wraps it up for us tonight. Thank you very much for joining me, everyone. And let's look forward to hopefully this comet making it to naked eye visibility by the 10th, 11th, night of the 10th, 11th, when it is at perihelion, when it's closest to the sun. And anything can happen with comets, as long-time Slooh members know. Anyway, I'm Paul Cox. It's been Slooh, another episode of Practical Astronomy. Thanks for joining me. I'll see you next week. I'll see you tomorrow, actually, first, but next week as well. Bye now.